In this video, I'm gonna discuss about chapter 7, the source-free RC circuit and RL circuit, the step response of an RC circuit and RL circuit. And the first is the source-free RL circuit. In this video, I will discuss source-free RL circuit, which is said to be source-free or walay source yang circuit. Okay. So diri sa analyzation nato sa RC circuit, ma-apply gyapon nato ang Kirchhoff's current law. It just we have capacitor with resistor. Nga dili na simple algebraic expression ang mabuo nato basta i-apply nato ang KVL or KCL. But using the differential equation, so natay storage element like one inductor or capacitor like sa circuit, we call that first order. So therefore we have a first order circuit is characterized by first order differential equation. Okay, so there is the first order circuit na ay duha ka ways para ma-excite ang circuit. Ang one way is if mag-charge sa inductor or capacitor, and then katong gi-charge aya na dayon to i-connect sa resistor, o katong stored energy sa capacitor or inductor iyarang i-dissipate lang sa resistor. Or ang pagkaduwa nga pamaagi is or two-way is to excite through the use of independent source or both DC and IC source. Okay. As you can see, natay circuit na may combination sa parallel capacitor and resistor. No other independent source or DC source. So apply nato KCL, which is it's say nga diri nga node A. Say nga summation of I is equal to 0 at node A. So since ang current nila kay diving sila duha, we can write this as IC plus IR is equal to 0. Okay, and let's assume that ang capacitor is at time equal to 0 na ay initial charge nga V of O is equal to V naught. Okay, with this we can find the energy stored in capacitor at time 0, which is W 1/2 CV squared. Okay, as you can see, we back to this formula, we have IC plus IR is equal to 0. If we evaluate both, which is ang IC is equal to C dV over dt, and ang IR is equal to Ohm's law lang, so V over R. If we combine both, we can get C of dV over dt plus V over R, and if we divide both by 1 over C, we can get dV over dt plus V over RC is equal to 0. And assume this is differential equation first order. You can solve this by using separable variable. If we apply those separable variable, we can get dV over V plus dt over RC, which is, we can transpose this in here, and we can get dV over V is equal to negative dt over RC. And we next, it's integrate both, integrate can get dv over v is equal to integral of v or negative dt over rc. So integral sa dv over v is equals to ln v equal negative 1 over rc t plus c. Since natay initial condition sa constant nga if time is equal to 0, capacitance ang natay condition sa capacitance nga if t is equal to 0 or v of o is equal to v naught. So you can substitute lang dayon. So you can get ln of v naught equal to negative 1 over rc of 0 plus c. You can cancel this one, 0 na siya. Mabili na lang kay ln of v naught is equal to c. Okay. So this one substitute lang siya diri itong ang ln v naught, so can get this one, and kaning 1 over negative 1 over rc is transpose sa diri, and kaning ln of v naught is i-transpose na nato siya diri can get 1 over rc t equal to ln v naught minus ln this one ln v. If you apply property of logarithm, can get this one 1 over rct is equal to ln v0 of v naught over v. Okay, if you make this exponent base e, can cancel this, and this will be muna mabilin dayon. So e raised to 1 over rct is equal to v naught over v, and this one will be the answer. So v is equal to v naught over e raised to 1 over rct, or using negative exponent can get v is equal to v naught e raised to negative t over rc, this one. Okay, so since ang voltage response for RC circuit is which denoted by this one, and it is an exponential decay of the initial voltage across the capacitor V naught, and since kaning energy is due to the initial energy stored in capacitor and not due to the external voltage or current source, we call that as natural response. So the natural response of a circuit refers to the behavior in terms of voltage and current of the circuit itself with no external sources of excitation. So if we graph the response, igani ang iyang waveform. As you notice, exponential decay from initial voltage as t increases up to positive infinity or greater than 0, it is slowly nagdecay or niubos ang voltage level, and then rapidly at which the voltage decrease are based in tau or times constant sa circuit. So the times constant of the circuit is the time that required for the response to a decay to a factor of 1 over e, or 36.8% of its initial value. So meaning at one time constant, ma-reduce ang initial voltage V naught sa 0.36 voltage percent, and we can solve the value of tau according to value of resistance and capacitance, which is equal to tau is equal to RC and measure in seconds. And if we listening kan RC to tau, you can get this one. Okay. Using the table, we can find voltage response sa fraction of initial voltage V naught by using different value of time, like times constant 1, 2, 3 until 5. And as you notice, while it's getting higher, the constant tau kaning value sa V of t over V naught kay gahinay-hinay og kagamay, no? Asa 5 tau, which is gamay lang kaayo. And we say that if we reach that stage, we can say that kani nga times constant ay nag steady state na siya sa circuit. Okay. If we consider a circuit with different time constant, manotice nato ang different rate decay based sa diri nga waveform. So diri nga waveform, no? So kaning 0.5 nga tau is lower siya, pinagagamay siya, but faster iyang decay. Mas faster iyang decay sa output sa voltage. Well, sa gikan diri sa 1, gataas ang as the time constant gataas, mas lower ang rate of decay. Kasi hinay as the time nga mutaas. Okay. So we can find the formula for the power dissipated in the resistor. Those we have P of t is equal to IR or VIR, or the voltage drop across the resistor and capacitor is equal to IR. So simply just V squared over R, where V is our step response, or voltage response, which is V naught e raised to negative t over tau squared over R, or simply just P of t is equal to V naught squared e raised to negative t over tau squared over R. And we can also find the energy dissipated using this formula, where integral of p dt from 0 to t, we can substitute the power using this one. So integral of V naught squared e raised to negative 2 t over R dt. And more simplification, so is equal to negative tau V naught squared over 2R e raised to negative t over tau, evaluated from 0 to t. Or just if we apply the energy, so 1/2 CB, or 1/2 C V naught squared of 1 minus e raised to 2 e raised to negative 2 t over tau. So this is our power dissipated. The key to working source-free RC circuit. Number 1, finding the initial voltage V0 V of O is equal to V naught across the capacitor and the times constant T. Okay, for the circuit below, let V sub C is equal to 0 is equal to 15 volts. Find the V sub C, V sub X, and I sub X for the time equal to 0. Since let's find, so may tawag na to ang V sub C. Since given naman yung V sub C, muna niya ang yung value. So, atong next may taon is kaning tau or time constant is equal to RC. Since itong capacitance is this one, 0.1 farad, ato na lang may taon sunod is iyang REQ equivalent sa circuit, which is if mangita tag REQ equivalent, ang capacitance mahimong kuan ma-open. So kailangan igani iyang forma sa iyang circuit. So if you redraw nato ning kuan circuit, you can get this one. Okay, so kaning 8 ohms o 12 ohms is series. So yadong na to na siya 20 ohms ang duwa. O igani na din iyang forma. Gani na dayon. So using current divider or current division or equivalent, we can get 20 ohms times 5 ohms over 20 ohms plus 5 ohms is equal to 4 ohm. Since na naman tayo resistance, na tayo RE equivalent, can now substitute this one. Okay, where R is equal to 4 ohms and itong capacitance nga 0.5 nga farad, which is can get 0.1 seconds. Next, atong pangitawon ang yang Vx. Or first, atong mag Vx kung itawon sa nato yang voltage response, which is this one. Using this formula, you can identify the voltage response. So V sub O, V naught is equal to 15 volts, and this one will be our substitution. So E raised to negative T over 0.4 seconds. So nakuha kanina nga for 0.4 seconds. O i-simplify pa nato, we can get 15 E raised to negative 2.5 T. And now we can find the Vx. So Vx equals to, using voltage divider, we can solve for the Vx, which is 12 ohms plus 12 ohms plus 8 ohms, and times 15 E raised to negative 2.5 T is equal to Vx is equal to 9 E raised to negative 2.5 T volts. And the last, we can find for the Ix, which is Ix is just a Ohm's law. You can substitute the Ohm's law like this, and substitute lang, which is atong Vx is kani siya, and yang resistance nga 12 ohms. So we can get 0.75 E raised to 2.5 T amps. So source-free RL circuit. To determine the circuit response, which we will assume to be current, through the inductor, we select the inductor current as the response in order to make advantage of the idea that inductor current cannot change instantaneously. So in this given source-free RL circuit, you can find QBL in this loop. Okay. So summation of V is equal to 0, and V sub L plus V sub R. Okay. Where V sub L and plus V sub R, if ato ni evaluate, so ang volt sa inductor is isa to L over di over dt plus VR, which is IR. Okay. Nara. So L of di over dt plus IR is equal to 0, and multiply both by L, and then like this, I'm canceling L, and then kani di over dt plus R over L I is equal to 0, and kaning R over L i-bali na sa dire, transpose, can get di over dt is equal to negative R over Li, where ito ni i-transpose ng dua, cross multiply ng I of dt, and get di over I is equal to negative R over L dt, which is ato nang i-integrate. So integral sa di over I is called lni, and integral sa negative RL over dt is equal to kanina gani. So this one, so lni is equal to negative R over L of t plus c. So natay condition sa inductor. So if t is equal to 0, where I of 0, I mean this one kanina lang kay is okay. So kani I of 0 is equal to I naught, we can substitute the equation like this. Okay. Ln of I naught is equal to R over L of 0 plus C, where kani is ma-cancel. Mabili na lang kay C. If we can substitute back, can get this like this. So lni is equal R over LT plus ln I naught. Okay. Where kaning ln I naught is transfer sa dire. Imo na siya kani. Where lni is equal minus ln I naught is equal to negative R over LT, and using quotient rule of logarithm can make this equation like this. So ln I over I naught is equal to negative R over LT. So this is na itong equation. So make both equation by E. So cancel na siya, and mabali na lang gani. So I over I naught is equal to E raised to negative R over LT, where or I of t is equal to I naught E raised to R over L t, wherein in constant time tau sa inductor is equal to L over R, where ato rin i substitute dere, you can get I of t is equal to I not e raised to negative t over tau. This is our current response sa RL circuit. Okay. Okay, if ato tong i-graph, say for example, diri atong initial current, and if the time is approaching to infinity, the decay or the young graph will be like this, which is approaching to 0. And then if the time constant tau, ang equivalent niya is 0.368 current. So base sa time constant, the lower the time, the faster the decay. So if the time is high, taas ang time, so mas slower the decay, like this. Okay. Now we can find the power dissipated in resistor, where P of t is equal to VR I, or simply I squared R, where ang substitute na to ang nakuha nga current response, which is I naught e negative t over tau 2 squared times 2 times R. Okay. P of t is equal to I naught squared e raised to negative 2 t na siya t dire over tau times R. And we can find also the energy dissipated, the energy across the resistor, which is integral of P of t dt from 0 to t, and integral of I naught squared Re to the power of negative 2 t over tau dt, and using the energy of the inductor, we can get negative 1/2 tau I naught squared Re raised to negative 2t over tau equivalent to 0 and t. Okay, yan, ito na yung i-simplify pa. You can get this negative 1 over 2 tau I naught squared R times 1 minus e pero negative 2t limita na po over tau. Okay, so if the time is approaching to infinity, kani po siyang portion is approach po sa 0, which is ang mabili na lang is negative 1/2 t tau I naught squared times R. So where time constant sa inductor is L over R. Ito na substitute. So negative 1 over R, negative 1/2 L over R I naught squared times R, where ato ning i-cancel, and we can get negative 1/2 L I naught squared. Okay, the key to working with source free RL circuit: number 1, finding the initial current I of 0 is equal to I naught through the inductor, the time constant tau, and of the circuit. Okay, the switch is off in the circuit of figure below has been closed for a long time. At t is equal to 0, the switch is open. Calculate the I of t for t of 0. So, ang circuit daw, kung i-analyze na to, circuit daw kay naka-close for a long period of time. So, it's saying let's consider this as t is less than 0, which is close ni siya. Since ang inductor is a open circuit to the DC, and kaniyang 2 Henry nga inductor will be short. And kani po iyang 16 ohms nga nakaparallel. Mabili na lang is 40 volts, 2 ohms, and 4 ohms, and 12 ohms. I-redraw na to kani ang gawas. Okay. Atong i-analyze, pwede ta mag REQ equivalent. So, resistor equivalent. So, 4 of 12. So, 4 times 12 nga ohms plus 4 plus 12 nga ohms is equal to 3 ohms. Wherein, kung atong i-redraw ni siya, we can get this circuit. So, using current division, we can solve for the current T total. So 40 volts over 2 plus 3 nga ohms is equal to 8 amps. So, namatay amps, we can get the I of L, I sub L. So, 12 plus, or current division formula. So, 12 nga kuan atong gi-consider plus iyang ohms, iyang kanin duha. So 12 over 12 plus 4 times 8 nga amps is equal to 6 amps. Okay. At time is less than 0. So, at time is equal to 0, atong switch is ma-open. So, ang mabili na lang is ang wala ni siya nga diri nga portion, ang mabilin is diri. Okay, kanila lang sila. Og naman to ikon diri inductor. Okay, so pwede ta mag R equivalent. So 4 plus 12 plus 16, which is just 16 over 2 is equal 8 ohms. And we can solve for the time constant tau, wherein L over RE equivalent. So 2 over atong inductor is 2 Henry, and over 8 nga total resistor na to is equal to 1 over 4 seconds. And for the current response, yung formula kani equals to I not e raised to negative t over tau. Atong i substitute to is 6. So 6e negative t over 1 over 4 seconds. Kung ato nang i-simplify pa get, can get 6e raised to negative 4 t amps. And wala siya final answer.